Today we are going to go through a LeetCode problem, a very classic one, the 200 number of islands. So for this question, we need to count the number of items in a matrix. If the 1 is stand for island and 0 is stand for the water. So if it's a 1 have a 2, the island have 4 directions. If those 4 directions is a 1, so we can count those islands as a 1. So this is the question today. So let's traverse the second example over here. So for the since this is a matrix, we definitely need to traverse every single element in this matrix. If this element is a 1, then we need to traverse 4 directions for this island to find they have adjacent island to count as a 1 island in general, right? So let's traverse the example 2. So for example 2, the first element is 1, so that means we need to traverse 4 directions of this one. But for the up direction and the left direction, we cannot traverse it because we're definitely out of bound, right? We only can traverse the down and the right. So first we traverse the down. Okay, traverse down. The down direction is also an island, so we need to traverse the 4 directions for this elements for this island. So for this one, we cannot traverse up direction because we already traversed before. So we need to mark every island when we traversed, after we traversed. And the same things, we cannot traverse left. So we traverse the right for this one. And for this one, island is also 1, this means we can traverse the 4 directions, but we only can traverse up direction because this one is not traversed before and it's an island. We cannot traverse the downside or right side because they are 0. 0 is not island, so we don't have to count. So after we traverse the whole things, so the whole area over here, we can count is 1 island because those 4 small ones are connected. So it's the same idea for this one and the same idea for this one. So you probably know the traverse way we go through the matrix is the DFS because for every single island we traverse 4 directions. So this is one ways we do this question. So we have another way to do this question is a BFS. It's the same idea. So for this one, it's the same idea. If we use the BFS, which means we need to implement it by the queue, we need to push the same direction, the 4 direction into a queue if it's an island, right? So for this element is 1, so we need to push 4 directions if it meets our conditions, which means it's an island, which means the position is not out of bound. We push it in the queue, and we pop every element in that queue and check one more time for that island we have connected islands or not in 4 directions. So for this one, we push this one and this one into our queue, and when we push out this first element, process the first island, we process another one, and for this one, this island, we can push this one into our queue because we cannot do the upside upside is out of bound. The left we cannot do because we already processed it. The right we cannot do because it's a 0. So the only things we push into our queue is this one. So right now for our queue we have the we need to do the same things in our queue until our queue is empty. Then we can say these 4 elements is a one big island, and then we go through the matrix to check another element, right? Okay, I'm going to share my code over here. So for this part, I use a way to mark my island, my visited island. If I visited, I will mark the same position in my visited matrix as a true. And I have 2 for loops to traverse every element in my matrix. If that element is 1 and not visited, so I will do either DFS or the BFS. So after I finish my BFS and DFS, I will increase my result. So there is two separate methods to implement my algorithm. The first one is a BFS, the second one is a DFS over there. So for my both ways, I use a valid method. It's a helper method to help me check the current island is the current my island meet my condition or not. If it's not, I return false. If return false, this means I don't need to check the 4 directions for that island, right? If it's true, that means I can do it. So this is my way to figure out this problem. And thank you guys. Bye. Thank you so much.